Good talk about shoes. That's going to be our intro. All right, today we're looking at, sorry I forgot to label it, this is 5.0. 5.0. All right, because if you've been going through the OpenStax College Algebra book, you can find your extra examples and such. You've probably seen this before a little bit. We're just going to hit it again because it'll come up later. I keep saying that. Maybe later won't happen. Quick review. When I solve this equation, anytime I solve that equation, I get two solutions, correct? The plus and the minus. Because a quadratic, this is going to come up next section, a quadratic crosses that x-axis twice, right? So you get your two solutions. All right, but hold the phone. If I have that equation, x squared equals negative 36, we can't square root a negative. That's a goofy gusset. When I plug in my calculator, it says there's an error. So they invented something called complex numbers, so I can deal with negatives. Now, do you guys know where complex numbers are seen? There is one real life application for complex numbers that I know of. There's probably more. Put them in the comments. But no, do you guys know what the real life application is? If you're an electrical engineer, you will see complex numbers. Okay, so we're going to spend a very little amount of time on them. Today's the day we do it, but that's in case anyone does something where they're any sort of a little bit of physics and stuff, they pop up. So I didn't do it. Someone created a number called I. They were very narcissistic. So the rule is I squared is negative 1. There's three big takeaways I'm going to want you to take away from this lecture. This is number 1. I squared is negative 1. That's a huge property. That's the property that pops up. In the SAT, that's the property that pops up. In the real world applications, is I squared equals 1. And that's because I is the square root of negative 1. Okay. So that's not number 2. Number 1 is I squared is negative 1. If you know that, you know a lot. You can actually do this whole homework in this whole section if you know I squared is negative 1. All right. That's pretty much the nitty-gritty. So a complex number has both an I and not an I. Okay? So a real number plus a fake number. A real plus imaginary is complex. Okay? It's like me and my friends. A real plus imaginary is All right. Point number 2 from this lecture. When you are dealing with I, you treat it like X. Okay? So this is major point number 2. If you have I, just treat it like an X. What's 2I plus 3I? 5I, right? I times I squared, right? Treat it like an X. Okay. Sound good? That's the 2 big points. What was the third one? Oh, there's one more. There's the third. I did look at this ahead of time. This chart's cool. Really, that's a big one. If you know that, the rest makes sense. So I'm not too worried about this. Sometimes on the old SAT, I haven't seen it lately, they'll be like, what's I to the 48th power? And to do that, what you would do is you just go 48 divided by 4 is what? 12. So equal amount, and it'd be 1. I'll show you guys that later. Now is not the day for that. All right, so let's do some problems. I think we're almost halfway through already. When I add, subtract, or simplify, if I see an I, treat it like any other variable you've ever seen before, right? Don't overcomplicate it. I know it says complex, but it doesn't have to be. Combine your like terms. 2 plus 9 is 11. 4 minus 3 is 1. You're done. Treat it like an X. Okay? What? Oh, I'm sorry. Beep. I wasn't done yet. This should be a pirate ticket. All right. Distribute that negative through. Combine your like terms. 6 minus 2 is 4. Negative 7 plus 9 is 2. All right? If you see a problem like that in the homework set, do you guys feel confident you can do it? All right. One thing to keep in mind, though, is I a variable? Treat it like a variable, but is it? No, it's like pi, right? You can do the same thing with pi. 3 pi plus 2 pi is 5 pi. But remember, at the end of the day, I is a number. Okay, I is a number. Keep that in the back of your head, especially if you end up answering. What about when we multiply and simplify? These ones get a little bit trickier. But still the same thing. If you foiled once, you foiled 100 times. The 6 goes through and hits both. So I get 12 plus 24i. Treat it just like a variable. Now when you foil, something wonky is going to happen. You might have seen this before. Gotta get loose. So 3 times 1 is, I'm going to do it over here so I have more room because I got some fly. 3 times 1 is 3. 3 times negative 4 is negative 12i. Keep the I. Negative 7 times 1 is negative 7i. But then I get negative 7 times negative 4. 7 times 4 is 28. And then what's I times I? I squared. So I told you guys we have 2 of the 3 rules we got to know right now. Number 1 is I squared is negative 1. And the other one is treat it like a variable. So I'm going to do 3 minus 19i. What's I squared equal to whenever I see it? Negative 1. Okay? Negative 1. That's going to be important because sometimes, have you ever seen an equation that's a quadratic and the quadratic equation comes out and you're like, oh, no solutions? It has solutions. They're just not real. So that becomes negative 28. So I get what? 3 minus 28 is negative 25 minus 19i. Okay? So again, do you guys see? Would you like to see another one? Because these are the trickiest ones we're going to see. Let's do the bottom one too. It won't hurt us. Negative 6 times 5 is negative 30. Negative 6 times negative 7 is positive 42. I. No. 9 times 5 is 45. I. And 9 times 7 is negative 63. Now I have an I times an I, which makes it I squared. All right. So what's my second thing I told you guys to keep in the back of your head? I squared is actually negative 1, right? So if I rewrite this, I could do negative 30 what's that? Plus 87i. What's a negative times a negative? Positive. Now make sure i's always have to go second. So we're used to, when you see a variable, you put it first, right? Like x's come before the constants. I's go in the back because it goes variables, constants, non-real numbers. I isn't real, so I has to hang out in the back. And you should always put yourself last to make sure everyone else has enough. So yeah. Yep, put the team before the person. All right, so this right here is probably the trickiest part of this section, is just foiling it out, taking your time with it, and remembering that I squared is -1, right? I'd be remiss, I still have to get to the next rule, though, for you guys. There's one more. There's one more rule. Oops, this part's relatively easy. I'm going to do this one briefly. A conjugate. You guys ever have to conjugate in English? Find the conjugates? I don't know anything about it. And when I took English, it wasn't a thing, actually. So, for any number a plus bi, the conjugate is a minus bi. So the conjugate of a complex number of a plus bi is a minus bi. Because when you multiply those together, the i's go away. The conjugate is made so that when you multiply it, the i's go away. Okay? I'll show you an example of it. It's quite indubiously. So let's do it. This is actually really nice. What's the conjugate of 1 plus 2i? 1 minus 2i. Okay? What's the conjugate of 2 minus 5i? 2 plus 5i. What's the conjugate of 3i? Ooh, what's the conjugate of 3i? Negative 3i. Because what's my number in front? 0. You know what I mean? I can treat it like 0. Now you don't have to write this part, but here's why it works if you want to know the why. So when you FOIL it, you do your 1, then you'll have a minus 2i, you'll have a plus 2i, and then you'll have a minus 4i squared. What will always happen in the middle if they're opposite sides? The middle will always cancel, so the i's will go away. That's what a conjugate does. It gets rid of the unrealness. And that becomes -1. I just got to go now. So it'd be, what, 5. So this times this is 5. Isn't that wild? It's not unreal anywhere. But again, can you guys, if I gave you a complex number, could you give me the conjugate? Okay, good. These aren't on the homework. I'm going to skip it. What? Yeah, it's on the test now. All right. Last 3 slides. So, oh no, there's no i's here. Rule number 3, that if you know you can do any of these problems. Rule number 3. Remember, square root -1 is I, right? So what that means is, I'll give you an example. If I have square root of -4, right, I can pull out the -1. Oh, I'm sorry, it wouldn't be -1. I can pull out the I, 2i, right? So anytime I see a square root of a negative, I just pull out an I, and it'll make it positive. Okay? Yeah, quite indubitably. So like on this beast, I would do 5 minus, what do I do here with that negative? I'm going to pull out that I. Ooh, that sounds gross. I have a good story about that. I think I've told some of my classes about an I being pulled out. 6 plus, pull out the negative 1. Oh. You guys see what I did there? Now can I calculate that? Of course I can. I can do difficult things. Let's go to 36. 6. And let's go to 81 is what, 9? And now it's just like our earlier problems, right? We just added the step of getting our I's out first. So 5 plus 6 is 11 plus 3i. Again, if you like to try this one and watch the video, by all means you can do so. But I have more that have examples like this. Let's do one of each. So let's do a multiplication one. And here's why I exist. Here's why I exist. Let's do this one. Well, we can do this one really quick. What do I pull out of here? An I. Right? And that just becomes 5i times 3, which is 15i. Okay? Hold the I, treat it like an x. So again, if you do those 3 rules, you can do any problem, right? Square root of a negative, pull the I out. Treat I like an x. I squared is 1. Okay? What can I pull out of both of these? An I, right? This is I square root of 45 times I times square root of 5, right? Ooh, what's I times I? I squared. 90, 180, 225. Right, when you multiply square roots, keep the bottom same. Yar. So that's 225. What's I squared? Negative 1. What's square root of 225? 15. You can use a calculator if you don't know your square roots. That's okay. And what's 15 times negative 1? Negative 15. So this is where I comes in play, especially when you're doing, I comment if I'm wrong, but in resistance calculations, you can get multiple square roots and negatives. And when you